Last time we were talking about delegates, and I gave you a quick guide of delegates and lambdas and how you can declare generic delegates. So if you haven't watched that video, you might want to go back and look at that first. But we're going to move on now and look at a related idea of events. Now, the place that everybody first sees events really is when we're dealing with GUI applications, either WPF or here I've just got simple WinForms. And so what we know is if we've got, say, a button on our form, I can double click on that and that gives us this button click event handler, and then I can write something to respond to that, like simply maybe a message box dot show and then thank you. And so having done that, when I run the program and click on the button, then we get the thank you popped up. And if we just take a look at what happened in the code in there, so if I look in my actual form, then we can see in here that is where it added my event handler onto the click event. And so the purpose of events and event handlers is to separate the concepts of when an event is raised from what should be done when it is raised. So it's up to the button to know when it's been clicked, but the button code can have no idea of what we want to do in any particular program when the button's clicked. So that's the event handler's job, and the two are bound together. Now, for the actual demo of this, I'm not going to look at WinForms because events apply in all sorts of other situations as well. And so I'm going to keep it simple with just a console application. What I've got here then is this simple class bank account. So all we've got is a balance. We've got a deposit that adds to the balance, and we've got a withdraw that removes from it. And then I've got a program that creates a bank account, makes a deposit and a withdrawal, prints out the balance. And if we run that, we just get balance is minus 500. And what we'd like to do here is use events to be able to signal to the client code when certain things have happened inside the bank account. So for example, if we go overdrawn, we're not saying you can't go overdrawn, but we need to notify the user, just like you get a text message or something like that nowadays if you go overdrawn with your own bank. So how do we do that? Well, first thing we do is we'd add an event. So if we go to our bank account, and we could declare an event first by declaring a delegate. So we might in here put public delegate, just like we did before, and then we declare the specification. So we'll put void, and then we're going to say account handler. And then when we're dealing with events, although the delegate in theory could be absolutely any type, any return type, any parameters we like, the convention is, and we should normally follow this, that we actually declare it as taking an object that we call sender, which is going to be the object that raised the event. So it could be the button, it could be something like that. And then we have this idea of event args, which is the additional information that tells us about the event. And so in my case, I've already predefined this account args that just has a message. So we could just put account args into there, and that would be our delegate matching the event. And then in our bank account, we could declare that. So we'd say public, and then the key thing is we say the keyword event, and then the type of it, account handler, and then the event we're responding to. So in this case, we're going to call this withdrawn. So that's declared our event. And then to make that work, we're going to say in here, if balance is less than 0, that's when we want to invoke it. We're going to say withdrawn. Thing we've got to watch out for is that if nobody has subscribed to this event, it's going to be null. So we have to put a safety check, which we do with the null propagation operator. And then we can just say invoke. And then the sender is this. And then new account args with a message, you are going overdrawn. And then back in our program, we can simply say BA dot, there we can see our withdrawn, plus equals, and then what I'm going to do here is just use a lambda. So we've got the sender and the events as parameters, and then I'm just going to say console write line, and we'll have message from bank, and then e.message, so that's our event args, and that should be all we need to do. So now, if we don't go overdrawn, so if I say only withdraw £100, it's okay, but if I withdraw £1,000, we're getting the message from the bank that we're going overdrawn. So that's the basic way that everybody's seen to use an event. We declare the delegate, then declare the event, then invoke the event when we want to. One thing to mention at this stage though, remember when we were talking about delegates, we talked about generic delegates with the things like the func and the action to save us doing a load of typing every time we want to declare a delegate. Exactly the same is available here, because the convention is that events are going to always return void and the first parameter is always going to be an object, and then the only thing really going to vary is the event args type. There is actually a generic defined for this. So what we commonly do here is use this predefined thing called EventHandler, which we can see is a generic that simply takes the event args type. So if I replace that with account args, that will achieve exactly the same thing, and now I don't need to declare a separate delegate. I still need to declare my event args if it's going to be anything other than the basic one, but we can now have that there, and the program works in exactly the same way. So that's the more common thing to do, save yourself a bit of typing. But the thing you want to ask yourself is, why is that different from just using a delegate? Why can't I just say that and have it work in the same way? And fundamentally that will work. But the problem is that if we just have a public delegate, then in our program, as well as being able to add an event handler and remove an event handler, we're also able to actually invoke that. So I can actually say .invoke and then raise the event. And that's not what you want. It's the job of the bank account to raise the event. It's the job of external code to respond to the event. So effectively, what we want to do is we want to have a delegate for which the plus equals and minus equals are public, but for which the invocation is private. And that's exactly what the event keyword does. Now, if we say ba.withdrawn on an event, we don't see the invoke method. We're not allowed to do that. So one simple way of thinking about it is to say precisely that when you've got an event, it's got public plus equals and minus equals, but a private invoke. In fact, it's a little bit more complicated than that. When we put in a event like that, what's actually generated under the covers is a bit more complicated. It's a bit like when we have properties. Remember, in C# we can have either auto-implemented properties or manually implemented properties. And what we've got here is an auto-implemented event, but I could equally write a manually implemented event. And the way I do it would be this. I would still have the same heading to it, but rather than just rounding it off with a semicolon, I would put, just like we have a get and a set on a property, we need to have an add and a remove on an event. And these correspond to the plus equals and minus equals that we use to add or remove handlers there. So that's what we have to do. And then, again, very much like with the manually implemented property, we would have a private backing field simply of the delegate type. And so I'd call that something like underscore withdrawn. And then all we've got to do in here is pass that add and remove through to the private delegate. So underscore withdrawn plus equals, and then within this add and remove, just like inside the setter for a property, we have the special keyword value, which is the event handler we're trying to add, or in the case of remove, it's the event handler we're trying to remove. So that's there in both of those. And then one last thing we've got to do down where we invoke it. We don't invoke it on the public event, we invoke it on the private delegate. And then if we just run that up, we'll see we're getting exactly the same behavior as before. So that's what we have, just that plus equals for add, that minus equals for remove, and that essentially is exactly what is produced when we had our auto implemented event. So when we said public event handler account args withdrawn, that generated the code that I've now put in here by hand. Now, in most cases, of course, we don't want to do it for ourselves. We normally use the auto-implemented one because it's far less code than having to do all that for ourselves. But what I'll show you now is a couple of situations where actually writing a manually implemented event handler is a really good idea. One is if we actually want to chain together events from a different class. So just to show you, what I've got here is I've got this interface called iAccountValidator with a event and a validate message, and then I've implemented that in this simple validator, and all the simple validator does in its validate method is if the balance is greater than a defined threshold, we say try opening a savings account, so we send that as an event, or if it's gone negative, we do similar to what we had before, we've got the you are going overdrawn. Now, first thing to notice here actually is a little bit about how events work inside interfaces, because we can see there I've got the event in the interface, and that's actually rather different from when we declare an event in a class. Because remember, when we declare an event in a class, that creates three things. It creates the add, it creates the remove, and it creates the backing field to actually store the delegate. But of course, in an interface, we can't have any fields. So an event in an interface simply sets up the requirement that anybody implementing the interface must provide the add and the remove. There's no further requirements as to exactly how they implement it. They've just got to make sure somehow there's an add and a remove. So that means that when it comes to the class can either do that automatically, which gives us an add and remove, or could have done it manually, as we saw in the bank account. But in this case, I'm just going to leave it to the automatic. So the way this is intended to work is what we could do is on our bank account, we could now have a private field of this iAccountValidator type. And then we could have a constructor. And in there, let's just keep things simple. Let's just initialize that validator to a simple validator with maximum of 1 million that we can put into our account before we get warned about it. And so then what we would do is down here on our deposit, we could just say underscore validator dot validate balance, and exactly the same code in there. So we've removed the functionality, put it into a separate class, and therefore simplified our bank account class, which is a typical sort of thing we might want to do. That said, the problem is now that all of those events are being raised in our validator, whereas they're being subscribed to from our bank account. So somehow we need to hook up an event raised in the validator with an event raised in the bank account. Now, one way you could do this would be like this. You could simply say, after you've created the validator, validator.validated plus equals, again, we've got the sender and the event args, and then simply say, when the validator raises the event, we are therefore going to raise our event. So we're going to say underscore withdrawn query.invoke, and then pass through the information that we want. And that will work perfectly well. If we run that up, we can see we're still getting the message from the bank, you are going overdrawn, but it's not particularly efficient because each step of the chain is doing its own processing. So if I put a break in here where the message is actually coming along and then run this up, that's the point where we're doing the validation. We invoke that event, and if we step into there, that means having invoked that event, we come into this function, which then invokes another event, and then we step into there is when we finally get to our message back in the main program. So it's not horribly inefficient, but you could imagine these sort of chains could build up. So one reason that we might want to have a manually implemented event is to actually save that, because what I could do here is, if we go to our bank account, I could simply, on my add for my withdraw event handler, I could simply say, don't add it to my handler, add it to the validator's handler. So in here, I could simply say underscore validator dot validated plus equals value. And in fact, I can make that even simpler, because I can use the expression bodied member syntax, the arrow, to actually make that even neater. So now we don't need to have our own delegate at all. And we don't need to put that one in either, because we're saying the actual event is going to be dealt with by the validator. And so in fact, both our add and in this case our remove is going to be very simple. We just do the minus equals there. Okay, and so what that now means is that simply by doing that withdrawn, it's delegating through there. So if we run that up, it still works in exactly the same way. But if we step through it in the debugger, we'll now see that when I step into the first invocation, we go directly to the function in main that we want to call. We don't have to go through the chain of it. So that's one use of writing your own manually implemented event if you simply want to delegate the functionality over to some other event in a different object. And it's quite a common thing that you'll see. The other use of it is if we take a look at, back on our WinForms application, if we take a look at the button and look at the events, we can see that that's actually got dozens, probably 3 or 4 dozen different events, very few of which anyone is ever interested in. Most people are going to be interested in the click on a button, but the fact that people are going to be interested in responding to the margin changed event is somewhat unlikely. However, just because occasionally you need those things, they've all got to be there. And bear in mind the way an event works. Each one of these events, if it were implemented as an auto-implemented event, would have its own private field where you store the delegate. And each one of those delegate fields is a reference, so it's the size of a pointer, so that's going to be 64 bits, 8 bytes per event, even if they're never being used. So this button, if we did it that way, would be carrying around absolutely tons of empty references to events that were never used, and it would be a huge waste of memory. So the trick that's actually done is you don't store individual delegates for each event. So let's look at how we do that in our bank account. I won't spend a great deal of time going through this. I'll just show you one I've prepared earlier. So what I've got is this very similar class, bank account multi-events. So we've still got the balance and we've still got the deposit and the withdraw with various checks in them. But what I've added is this. You'll see that I've put in this dictionary, and it's a dictionary that's keyed on string, which is going to be the name of the event, and then the actual event handler. And then I've written 3 private methods. One of them's called add, so we can add a particular named event handler. But the important thing to see what it does is it looks to see if we've got an entry in the dictionary for this particular event handler. If we don't, then that will just create that entry for that named handler. Or if we do, we'll just add on to the existing one. And then similarly on a remove, we look to see if we've got an entry, we remove the handler from it, and if it's the last one that's gone, we remove the entry from the dictionary altogether. But the important thing is, because we're storing these in a dictionary, the dictionary only takes up as much memory as is needed. So unlike with the naive approach, we don't just have one reference there waiting for each one of the events. If nobody subscribes to any events, then the dictionary will be empty. And if people subscribe to 20 events, then the dictionary will contain 20 entries. So it just expands to fit. And it's far more efficient in terms of memory. So I've got my add and my remove, and then I've got this invoke, which again just looks up this particular named event, and then if there is one there, it invokes the event handlers for that one. Then this is where I need to have the manual implementation, because now I've got these two events, withdrawn and deposited, but I don't want them to be auto-implemented and have their own storage. So in the add and remove, I simply call the add and remove I've already written, passing in the name of either the withdrawn event or the deposited event. So very, very simple. It is a bit tiresome writing this code out for each and every one of your events. I pity whoever originally wrote that button class, basically having to write this out 30 times or whatever, but it's an effort for the programmer. That's a one-off. In terms of memory, it's going to save you a lot. And then in our deposit and withdraw, we check on the balance, either for going too high or going too low, and then we invoke either the deposited or the withdrawn handler with the appropriate message. And so now if I go back to the program and replace that bank account with bank account multi-events, we can now see it's still going to work on the withdrawn, but let me also put in one for the deposited. So let's make this clear. We'll have a withdrawal message from the bank, and we'll have a deposit message from the bank. And then, having made that withdrawal that takes us overdrawn, let's have a deposit that puts us over. And so now when we run that, we're seeing we're getting both the messages for the withdrawal and the deposit. But if we didn't bother with one of them, if we say got rid of the withdrawn, then we've only got the one message, but more importantly, we're not wasting memory storing an empty delegate reference that's not being used in this particular case. So we've seen there how delegates are related to events. We've seen if you write your standard auto-implemented event, then you get three things. You get the add method, the remove method, and then the private field containing the delegate itself. And we've also seen situations where you might want to actually manually implement that. We've seen the situation where if you've got lots of events, you can save memory by storing the delegates in something like a dictionary, which will expand to fit. Or we saw the situation where if you want to forward an event from one object to another, like we forwarded from our simple validator to our bank account, then you can use a manual event again to set that up without having to go through a whole chain. So I hope that made sense. Have a look at the code on GitHub for everything's filled in, and see you next time.